an introduction to logarithms. So we're going to be working our way through these problems here. We're going to start off with this one. What this is saying is, if we're counting in a times 4 kind of way, how do we get to 64? How many steps is it going to be? This is the way that we're going to be thinking about it. So we're going to start off at the number 1. We haven't gone any steps so far, we've gone 0 steps. Every time we go along here, we're going to times by 4 once. So if we went 1 step along, we'd be at 4. If we did another step of timesing by 4, we're now at 16. The question here is, how many times do we have to go in steps of timesing by 4 to get to 64? Well, that's going to be the very next one, because 16 multiplied by 4 gives us the 64. So the answer there is 3. So we can say that that one equals 3. This is the game we're playing with each of these. Some of them are going to be a bit harder. So let's look at the next one. On this one, we are going along in a times 8 kind of way, and we're trying to get to 32. Now the immediate problem here is 32 is not a nice power of 8. We start off at 1. If I times by 8 once, we're at 8. If I times by 8 again, well, the problem is we overshoot. We're now at 64. We need to go in something less than a full step here. Here's the trick. I'll do it in a second colour. What we're going to be doing is breaking down these steps into sub-steps. So what we could do, instead of going by 8 in one step, we could go in 3 equal-sized smaller steps. Multiplying by 8 is the same as multiplying by 2 3 times. If we worked out where we were along this graph now, 8 multiplied by 2 gives us 16. 16 multiplied by 2 gives us 32. And then 32 multiplied by 2 gives us the 64. So it's like we split this whole thing into 3 equal pieces here. To get to 32, which was the target, we went 1 plus another third plus another third. It's like we're now at 1 2/3. We can leave our answer like that. So that is 1 2/3. If you want to write it as a top-heavy fraction, so 5 over 3, that's fine too. But in some ways this is more descriptive, because we're saying how many whole jumps have we made and how far through the next one. Right, one more like this. Let's have a go at this one. Now the problem we have here, put it into screen, is that as we multiply by 5, we're getting bigger. Our target is a small number. Instead of going this way along this line, what we need to do is go backwards along the line. So if we drew a few more steps in going to the left, the -1th step, well, that's multiplying by 5 to go that way, to the right. To go backwards, it's like we're dividing by 5. To get to 1 over 125, if we went 2 steps back, -2, -3, we're at 1 over 25, 1 over 125. So, to get to that, we have gone 3 steps to the left. Our answer there, then, is -3. Now, what I'm going to give you to have a go at are some problems. Okay, here are the problems for you. So, pause the video, have a go at them, and then when you unpause, I'll go through them. Okay, so for each of these, this first one, if you count up in a times 7 kind of way, times in by 7 once we get 7, times by 7 again we get 49, and so 2 times. This one's probably the hardest one here. Timesing by 4 once we get 4, by 4 again we get 16, then 64, 256, but unfortunately the next one that we do, we overshoot to 1024. What we need to do is split the 4 into 2 steps of times by 2. So 1 step, 2 step, 3 step, 4 step, 5 step, we need to go half a step here. And so our answer is 4.5. If you wrote something like 9 over 2 or 4.5, that's fine too. But I would avoid the top-heavy notation for fractions in this, because this is so much more descriptive in terms of how many whole steps and how many parts of steps. This one is -3 because we're going 3 to the left. And then this one, what power do we have to take n to get to n to the 7? Well, 7. Or, to phrase it in a slightly different vocab, how many steps of size multiplied by n do you need to do to get up to n to the 7? Well, 7. Right.